Lesson 9 out of Unit 8 with me, Miss Billman. We're looking at the mean absolute deviation for this one. So we're going to be using the dot plot below, and it has the mean of these values is 5. So I'm already going to mark the 5, or at least kind of know where I'm at, and then start labeling. How far away is 1 from 5? It's 4. And I put 2 4s because there are 2 1s. Now, how far away from 5 is 6? It's 1 point. How far away is 8 from 5? It's 3. And how far away is 9 from 5? It's 4. So, hooray, I found the distance from the mean. Now I need to find the sum of these distances. So 4 plus 4 plus 1 plus 3 plus 4. So 4 plus 4 is 8, plus 1 is 9, plus 3 is 12, plus 4 is 16. So next step, I need to divide the sum of the distances by the number of values. So how many numbers did I add up? 1, 2, 3, 4, 5. So 16 divided by 5. I'm going to pull my answer over here. How many times can 5 go into 16? 3, because it's 15. 1 decimal point, bring that down, and 5 goes into 10 2 times. So I get 3.2. What does the answer in exercise 3 represent? This is a great question. When we look at the absolute deviation, the mean absolute deviation, it's like how far on average those numbers deviate, so like go away from the mean. Follow the steps below to calculate the mean absolute deviation of the data in set A shown at the right. So we need to find the mean of the data. Okie dokie, 5 plus 8, that is 13 plus 4, 17 plus 5, or I can combine them and do 8. It's 25 plus 9, 34 plus 6 is 40. Now, and I can write that in on number 5 once I divide. So I divide 40 by 8, which I know is 5. So the mean for that set is 5. Now I need to find the distance each value is from the mean. So 5 is equal to 0. It's 0 units away. 8 is equal to 3. And I will label that units. 4 is equal to 1 unit away. 5 is 0. 3 is 2. 4 is 1. 5 is 0. And 6 is 1. Now, it brings up a good question about having an 8 and a 5. They're over the mean, so it's not like I can say 5 minus 8, which would give me negative 3. That's not part of this. I would actually say how far away is 8 from 5, and it's still 3. So now I'm going to take all those numbers, 0, 3, 1, 0, 2, 1, 0, and 1, and I'm going to add them all up and get the sum of my distances. So 0 plus 3 is 3, plus 1 is 4, plus 2 is 6, plus another 2 is 8. Now I need to calculate the mean absolute deviation by dividing the sum of the distances by the number of values. So I will be dividing 8 by 8, and that's 1. In exercise 8, you calculated the mean of absolute deviation for data set A. Suppose the mean absolute deviation of a different data set called B, where's that B, is double your answer for exercise 8. How would the spread of data in the two sets compare? So this has a mean absolute deviation of 1. So that's telling me these numbers are pretty darn close together. Now, if I were to double, that would mean I'd have, well, for one, a larger spread, right? The data in set B would be more spread apart. The closer it is to a 0 or 1, that means it gets closer.